All right, and a vertex is that minimum or that maximum. If it's a minimum, what kind of shape would we have? Yeah, it's like a U. It goes down and then up. Good. It's kind of like a right side up U. So this is our minimum. We're going to talk about that in just a second, Andrew. Hold on to that thought. And that happens specifically in our equations when A is positive. It's always going to be a minimum if A is positive. I'm going to use one color today for A. Every time I see A, I'm going to use the color red. If you would like to use a color, if you want to use red, you can. So grab that colored pencil out. So A, we're talking about this A up here, that very first number, that first coefficient. If A is positive, it'll have a minimum. And I kind of think of it like how Andrew thought of it. What does that look like if I'm positive? Means I'm generally happy, and if I'm happy, I'm smiling. So it kind of looks like a smile. Okay? So A is positive. Another way to write that is A is greater than... What number does A have to be bigger than in order for it to be positive? 0, yep. So for some people that might be a better way to write that. If that makes you like, I don't know what that means, just think positive. Alright, our other option is that it could be a maximum. That kind of makes it look like a hill or a frowny face. All right, and this is going to happen when A is negative. Okay, and where are numbers that are negative located? Below 0. Whoa. A lot happening there. All right, so another thing about our vertex is the vertex is always going to be, for an ordered pair, we're always going to have this negative b over 2a. It's going to be our first part of our ordered pair for the vertex. That's really important that we write that down. Really, really important. If you write anything down from today, main big idea for today that's really brand new. All right, now this part here, we think of that minus sign kind of as a negative. Another way to think about it is as opposite. And that's how we're going to think of it. Opposite of B. And that's how we'll say it. We'll say it opposite of B. Because that will help if it's a positive, what's the opposite of a positive? A negative. So that's easy to see, okay, it'll be negative. But what happens if B was negative? We want it to be positive. Good. All right, anytime I see a B today, I'm going to use the color blue. So if you would like to use blue for B, you can. I'm going to go back and color that up here, blue. Or just pick a color. Doesn't matter which color. It doesn't have to be blue. So opposite of B over, and then 2 and A are touching. What does that mean when we have 2 and A touching? Times A, good, multiply. So 2 times A. And again, that A is really important, so I'm going to color that in red. Es muy importante. Vamos. All right, you're going to be getting 2 graphs. I'm going to glue in my graph first on the right side. I want to leave a lot of space in one spot to show work. Let's just glue in 1 graph for now. Just 1. You're going to get 2, but you're only going to glue in 1. When you glue it in, make sure that Y is up on top. That's going to make sure that your graph is in the right position. So I'm going to glue that in on the right side of my paper. If you're somebody who you want to glue it on the left side, that's fine. You can do right or left. But we're going to glue it in on one side of our paper. Make sure the Y is on top.
Make sure there's enough space for you to do the equations and stuff too.
So either on the left side or the right side. All right, here we go with example 1. Oh, we just got finished handing those out. Sorry. Still handing them out. Give you a second here. Should be good because Miss Merrill needs it to get to our website so I can show you something. You're gluing in 1 graph just on the left or the right side. Leave a lot of space for work on the one side. So just glue in just 1 graph. The bottom of the page, I glued it in on this right side. All right. Number 1, we have 2 examples that we're going to graph today together, and then there is a quick check, however it's on paper today.
No.
You're lying.
Excuse you, Ruby. Sometimes they're not filtered. All right, number 1, we have negative x squared. Sorry, we have y equals, shoot, I missed my y, I'm sorry. Y equals negative x squared plus 2x minus 3. All right, our first thing we need to do is we're going to identify that A, B, and C. We're going to decide what is our A, our B, and our C. So A is our first number that goes with that x squared. What number is in front of that x squared? Good. If there's not a number that we see, what number is secretly hiding there? A 1. But it's not just a positive 1. It's a negative 1. Good. A is negative 1. What is our B? 2. And what is our C? Negative 3. Good. All right, so let's take a look at that. A couple of things it tells us. If I look at my A is a negative 1. Is this going to be a happy face or a frowny face? Good, frowny face. If it's a frowny face, is that a minimum or a maximum? Maximum. So this is a good way for us to double check that when we're done, let's double check and make sure that we have a maximum. All right, our next step is going to be to find the vertex. Our next step is to find the vertex. All right, so to find our vertex, we use our formula, opposite of B over 2A. What is our B? 2. Good. And on the bottom, we need to know our A. So on the top there, I have to think opposite of B. So what is my B again? 2. What's the opposite of positive 2? Good. Negative 2 over 2 times, and then I need my A. What is my A? Negative 1. All right, we can throw that in our calculator. Negative 2 over, so divided by, 2 times negative 1. And our answer is positive 1. After we do our vertex, our next step is now to make that input-output table, because we need both x's and y's. So my next step is to make a table. Which part comes first in our table? X, and then y. Now, we found the vertex already, where it's going to be located. It's going to be located at 1. Is that 1 an x or a y? Yeah, it's going to be an x. So when I look at that x, where is the vertex located in our parabola? Is it at the beginning, the middle, or the end? The vertex? The middle. So I'm going to put that 1, whatever I got there, I'm going to put in the middle of my table. So I'm going to put a 1 right in the middle. And I'm going to create my table around that 1. So what would go above 1? 0, negative 1. And then what goes below 1? 2 and 3. 5 numbers is a good way to do these ones. I'm always going to ask you to do 5 numbers for these tables because it's a good way for us to check our work as we go. All right, for our input and output table, we're going to follow our rule. Our rule is negative x squared plus 2x minus 3. So in my calculator, I'm going to do negative. And then anywhere I see an x, I'm going to do a parenthesis. So parenthesis.
Oh, wait, is that for the graphic calculator?
Squared. So we can use a scientific calculator, but yeah.
Okay. I'll use my graphic calculator. I want to see what it is.
Plus 2. And then instead of x, what are we going to put in? Parentheses for our x, and then it ends with minus 3. So if you want to write that down, so if you're not doing this on your calculator with me, you might want to look back at this to see how we did it.
Wait, what was the x again?
We don't know yet. We're going to use it from our table.
I'll just put x.
All right, now using Desmos is going to be really important here instead of using your phone calculator, because Desmos is going to actually do this in the appropriate order. And I'm going to show you something kind of cool about Desmos that works. All right, so in Desmos, whoops. All right, what I can do is I can just type this in down here. So I'm going to do negative, and then I'm going to do parenthesis, parenthesis, squared. So that squared is at A2 plus 2, and then parenthesis, parenthesis, minus 3. But now it doesn't tell me an answer because I do need to put a number in for the x. So what's really nice is I can just go over and click into those parentheses and put in a number. So what is the number for our first x? Negative 1. So I'm going to put negative 1 here, and I have to put a negative 1 in the second spot there. And my answer is negative 6. Okay, our answer we get there is negative 6. So when I put in negative 1, we get out negative 6. All right, now what I'm going to do is instead of typing this all over again, I can click to where that negative 1 is, delete the negative 1, delete the negative 1, and what am I going to put in instead now? 0 for both. And we get negative 3.
Now, if you're using your phone calculator, you'll notice that you have to rewrite everything from scratch. So with Desmos is when you don't need to rewrite everything.
All right, instead of 0, what number are we going to put in next? 1. And we end at negative 2. Now that's our vertex. That's our highest point. Our highest point is negative 2. So what should happen in the next number? It should go back down. Good. So instead of 1, we're going to put in 2. And went down to negative 3. So that's good. What do you think 3 might be?
Negative 6.
Negative 6. How'd you get that?
Because negative 1 was negative 6.
Yeah, so what's the pattern, Ruby?
The vertex. It's 6. It's negative 6, negative 3, negative 2, negative 2, and go back.
So these negative 3s match around that vertex. Good. That's that axis of symmetry. We said they're kind of matching as they go away. So if I put in 3, this is a good way to check to make sure we did everything right. Did we get negative 6? Yep, we sure did. So that's a good way for us to check to see if we're doing it correct. All right, now we're going to go to our graph. Remember, we have our x and our y. So we have negative 1, negative 6 first. So on my graph, negative 1, is that up, down, left, or right? Left 1 first, and then down 6. All right, our next point, we have 0, negative 3. So am I going to go 3 left, right, up, or down? Down. Good, it's for the y. So just 3 down, right on that y-axis. Escribes los puntos. Next, I have 1, negative 2. So which way will I go? Over which way? Right 1, down 2. What's our next point? 2, negative 3, so write 2 down 3. And then 3, negative 6, so write 3 down 6. As we connect these points, we're going to try and make a curve at the top, and that's something that takes a little effort, takes a little while for us to get to the hang of. So it's going to go up, go through those points, it's going to get this curve at the top, and then come back down. So try and make that kind of a curve at the top there. All right, where we write, does it have a maximum? Does it match as it goes its way down? Perfect, we did it. Good job. All right, we're going to do one more together. So I have to go to my next page because I'm out of space. If you want to try and work ahead, you can, but it'd be a good way to make sure that you're stopping every now and again to see if what you got is right. All right, so I'm going to go to the next page, going to number 2. Number 2, we have 2x squared. Sorry, y equals, Miss Morrell. Oh my gosh. Y equals 2x squared minus 8x plus 4. All right, if you didn't glue in that second graph yet, now would be the time to glue that in. If you want to glue it in on the side, whichever side makes sense to you, make sure that y is on the top. That's going to make sure that you have the right numbers in the right places. Remember, you don't need to go crazy with that glue, just nice and easy. And then make sure that y is on top. So for our first step, what are we going to be finding first? For our first step, what are we finding first? We're going to find our A. What else? B and C. Good. All right, A. Really important because that one we're going to use a couple of times. What is our A? Just the 2. Just that number in front. So just 2. So before I even fill out the rest, is this going to be a happy face or a frowny face? A frowny face. So if it's a, what? Is it positive or negative? Positive. So if it's positive, is that a happy face or a frowny face? Happy face. Or positive. So if it's a happy face, is this going to be a minimum or a maximum? Minimum, because it hits that bottom and then it goes back up. I'm going to just write min next to it for minimum. All right, and then B. What is our B? Good, negative 8. How did we know that that was going to be a negative? And well, usually when we read it, we don't say negative 8 here. How would we have said that negative? Minus. Good. You guys are so smart. All right, and then what is C? Yeah, but sometimes we just need to make that connection in our brain that minus means negative. Some of us are still working on that. All right, and then what is C? 4. All right, next step. We need points. In order to make points, we have to make a table. But before we can make a table, we have to know where to start, where that vertex is going to be. So our next step is to actually find where is that middle point going to end up. Where is that vertex? So for our vertex, we're going to do opposite of B over 2A. Give us 1 second, Dane. Okay, if it helps to color code that so that you can see. All right, so what is our B this time? -8, and that's where that word opposite is really important to us, because what's opposite of -8? +8. So we're going to do +8 over 2 times 2. Which some of us can do that in our head. If we're doing it in our head, which part do we do first? The dividing or the multiplying? Good, that multiplying. It's together on the bottom, so we would need to do that multiplying first. So we would do 2 times 2 is 4. And 8 divided by 4? 2. All right, next up we're going to make a table. And a table has our inputs and our outputs, so our x's and our y's. But we can't just put in any random numbers, because then we're just going to keep putting numbers in, numbers in, numbers in. We want to center our graph. We need that middle number. What is our middle number going to be? 2. Good. We use that vertex, that 2. All right, and then we're going to go 2 above 2 and 2 below 2. If you do yours backwards, it's okay. So if you think 2 above 2, if you do 3, 4, that's fine. Some people instead are going to think what in above 2? Yeah, they might do 3, 4. What else might they think though? 1, 0. Doesn't matter. So let's do 3, 4. That's the way my brain works. And what would be below 2? 1, 0. All right, in our calculator, we're following our rule. Our rule goes back to that equation. We have 2, and then instead of x, we're going to use parentheses. So x squared minus 8x plus 4. All right, I'm going to use that calculator because then that way I can just type this in and then I can just delete, and that's going to make it a lot easier rather than having to retype it. So 2 parentheses squared minus 8 parentheses plus 4. All right, what numbers am I going to put in those parentheses to start? We did 4. So when I put in 4 for both, what do I get out? 4. Crazy. All right, now it's a minimum, so is it going to be going up or down now? It should be going down to that minimum. So now instead of 4, we'll put in 3. And we get -2. So did it go down? Good. Double check, we're going to our minimum now. So to go to the minimum, is it going to be going down or up? Down. So we're going to put in 2, delete the 3's, make sure we do both. We get -4, so did it continue to go down? Yep. Can we take a guess at what might be the next number? Why would it go up to -2? Good. It's that, what's that S word that we talked about? Symmetry. Good. It mimics it. It's even. So it should go to -2, but this is a really good way for us to check our work. So if I delete that 2, what number were we putting in? 1. Do we get out -2? Yep. So that means we're doing it right. If this doesn't match, more than likely our vertex, we got the wrong number there. Okay, and then instead of 1, we're going to put in 0, and what should we get? Hopefully 4. Yep, goes back up to 4. All right, last step. Finally, is to do what? Graph. Good, so we're going to start with those points, 4, 4. So from my origin, we go right 4, up 4. Three, -2. Right 3, down 2. Nice, whoever said that. There's a couple of people going along with it. 2, -4. That's our minimum. So now it needs to curve back up. 1, -2. And then it should match. Some people, when they graph, they don't even need to look at the table at this point and look at points. Some people can be really visual. I'm not. And they can be like, oh, here's this point, so here's this point. And they can just look and be like, oh, this point, it'll match that point. This point will match that point. And that's just how their brain works. For me, I have to actually locate it. My brain doesn't work that way. All right, this one especially kind of looks like a V. So what's really important, or not really important, but what you're going to try to do is when it comes down to that vertex, try and make that curve around. And it's not probably going to be perfect. It's a little bit hard to do that as you learn. But try to make it more of a curve as it hits that vertex, not just down and up. We don't want a V, we want a U.